Ladies and gentlemen, welcome to this lesson, Doppler's effect, treating previous question paper. In this lesson, we will be treating 2015 November question paper. If you haven't subscribed to this channel, make sure that you press the subscribe button, you press the notification button over there, then you will get notified when we post videos. Take note that we have got two full videos which are teaching general content about Doppler's effect. Then this one, we are just treating a previous question paper to test ourselves if we understood the two videos which are teaching content for Doppler's effect. Okay, before I get in the details of the question paper, I want us to take note of one thing. I want to emphasize one thing before I get into the details of the question paper. Ladies and gentlemen, if we have a sound source, and we have a stationary listener, this one is stationary. Let me say V is 0 and V is 0 meters per second. The velocity of this car is 0. The velocity of this listener is 0. So both the listener and the listener and the source, they are stationary. If this car or this ambulance produces a sound which have got frequency of 630, if this sound source produces frequency of 630, this 630, it is the very same amount of frequency that this listener is going to perceive. It means that this listener is going to perceive how much? 680. So the frequency of the source and the frequency of the listener, they are going to be equal because the source and the listener, both of them are stationary. They are not moving. So you need to take note of that when the source is not moving and the listener is not moving, the frequency that is going to be produced by this source is the exact frequency that this listener is going to perceive. But when one starts to move, what is going to happen? This frequency is going to change. When this listener comes closer to the source, then what's going to happen? The frequency that was 630 as it is produced originally by the source, it will be increasing as this listener is coming closer to the source. But the source frequency, since the source is stationary in this case, it will remain being 630. But if this listener gets closer to the source, it will start to increase because the listener is coming closer to the stationary source. If the source moves, if the listener moves away from the source, this 630 frequency, it will start to decrease because the listener is moving away. So I want you to take note of that. It is very important. For example, if you are told that the source is stationary, then even the listener is stationary, the source and the listener is stationary, then the frequency of a listener is equals to 345. Yes, the frequency of the listener is 345, right? Both of them are stationary. So because both of them are stationary, what does it mean? It means that the frequency of the source is 345. This frequency that is perceived by the listener who is stationary, it is equal to the frequency that is produced because both of them are stationary. That's what I wanted to emphasize as we begin this lesson for treating 2015 question paper, November, physics, Doppler's effect. Okay, I repeat for the last time, if the listener and the source are both stationary and you are told that the frequency of a listener is 345, it means this 345 is also the frequency of the source because they are both stationary. What this listener is going to hear, it is what is produced original because both of them are what are stationary. So take note of that. Ladies and gentlemen, I welcome you once more. Let us start to treat this question. I have a previous question paper here, 2015. Question number 6. It says the data below was obtained during an investigation into the relationship between the different velocities of moving sound source and the frequency detected by a stationary listener to each velocity. The effect of wind was ignored in this investigation. Then we are given the results. I can write the result of that experiment. I can write the result of the experiment. Here we have got the velocity of sound. That is the velocity of sound. Then we have got the frequency. We have got the frequency detected by listener. Frequency detected by listener. Right? Then here are the result of that experiment. The experiment was repeated 4 times. Here are the results. I want to write them on the board as you still read the question as it is appearing on your screen. Okay. So, okay, that's what we have. Okay, let us come back at it. You can see now I just summarized the results by writing them on the board so that we can be able to work on them together easy. The first question is said, write down the dependent variable for the investigation. 6.1.1. 6.1.1. Write down the dependent variable for this investigation. What is the dependent variable? A dependent variable is a variable that changes during an experiment. A dependent variable is a variable that can be changed by the experiment. What is a dependent variable in this situation? Look at it. The velocity of sound, it cannot be changed. The velocity of sound source, let us correct it. Velocity of sound source, not just the velocity of sound. It's the velocity of sound source. It's the velocity of that which produces the sound. So the question wants us to write the dependent variable. A dependent variable is a variable that is going to change in an experiment. It's a variable that can be influenced by something in an experiment. What do we mean? It means that if another variable does something, the dependent variable will also need to also do something. It will also need to shift. It will also need to increase or decrease. An independent variable, it cannot be shifted by anything. It cannot be shifted by anything. So for that question, the dependent variable, that is the frequency detected by listener. That is the frequency detected by listener. Frequency detected by listener. That is the dependent variable. Why am I saying it is the dependent variable? It is because when the sound source moves closer to the listener, the frequency is going to change. When the source moves away from the listener, the frequency is going to change. So this frequency detected by a listener, it is depending on the speed. It is depending on the speed of the sound source. When the sound source moves away, the frequency decreases. When the sound source moves closer, the frequency increases. So obviously, the frequency detected by the listener is a dependent variable. The frequency detected by a listener is a dependent variable. Okay, then let us go to number 2. Number 2 says state Doppler's effect in waves 6.1.2. State Doppler's effect in waves. Okay, Doppler's effect, it is the apparent change in the frequency of a wave because there is because the sound source and the listener, they are moving at different velocities to the sound propagation. It is appearing on your screen. I won't pay much attention to the definition. Okay, then let us go to 6.1.3. 6.1.3. 6.1.3, it says that was the sound source moving towards or away from the listener, then give your reason. Was the sound source moving away or towards the listener, then give the reason. Let us check that question. The question was saying the data below was obtained during an investigation into the relationship between the different velocities of moving sound source and the frequencies detected by a stationary listener. So if we look at the results, if we look at these results, we know that the listener that listened to this sound was stationary. And in this case, the sound source is also stationary because the velocity here, it is 0. So what does that mean? It means that, remember I just indicated to you that when the listener and the source, when the listener and the sound source, both of them are stationary, what's going to happen when the listener and the source are both of them are stationary? It means that if a source produces 900 Hz, the listener will hear 900 Hz. The listener is going to hear 900 Hz. Both of them are hearing 900 Hz when both of them are stationary. It means this 900 Hz is the frequency that is produced by the sound source originally. And even the listener will hear the original frequency because both of them are not moving. So it means this 900, this 900 is what was produced by the what? By the source. And that will be exactly what the listener is going to hear because both of them are not moving. We know that the listener is stationary. Even here, the source is having a velocity of 0 meters per second. So we know that the source is producing 900 Hz. Even the listener will hear 900 Hz because both of them are not moving. But we can see that frequency is decreasing. So through our result, the frequency is decreasing. So what causes a frequency to decrease? Frequency is going to decrease because the listener is moving away from the source. The frequency is decreasing because the listener is moving away from the source. So the answer for 6.1.3 is away. Why is it away? Is because because there is a decrease. There's a decrease in frequency. The decrease in frequency indicates that the sound source is moving away from the listener. That's why we have a decrease. We can also include that there is an increase in the wavelength. When the wavelength increases, then there's going to be a decrease in the frequency. So that's how we are supposed to answer that one of 6.1.3. Let us move forward. Let us move forward. Okay. We're treating a question paper 2015. 2015 November. Then the question says, use the information in the table. Use the information in the table to calculate the speed of sound during the investigation. The question wants us to calculate the speed of sound during the investigation using this information, which is very lovely. Then we are going to start by writing our Doppler's effect formula. Remember, I've advised that when you write the Doppler's effect formula, we know that you can manipulate it and change it based on how the question is asked. But it is advisable that write the equation as it appears in the formula sheet to avoid the situation of manipulating it wrong, then you lose a mark. So I'm also going to do the same. I preach what I do. I do what I preach also. So I must preach what I do and do what I preach. Then I'm going to have V plus or minus VL over V plus or minus Vs, then Fs. I know that this formula I'm going to manipulate it, but for the formula, for the sake of getting 1 mark without losing anything, because learners are different, I must make sure I copy it as it appears. You understand? Then I start to solve. Then I said the frequency of the listener. Remember that for this investigation, the listener is doing what? There was a time where the listener was not moving when we started our investigation. Then later on, the listener, there was a time where the sound source was not moving. I'm sorry to say that because the listener is stationary for the whole experiment. The velocity of the sound source have changed. There was a time where the sound source was stationary, then it started to move. So we need to take note of that. So to solve this question, the frequency of the listener, we can choose any frequency other than this one, because here it's when the source was not moving. Starting from here, when the source moved 10 meters per second, when the source moved 20 meters per second, and when the source moved 30 meters per second, we can use any one of them, but we need to use them with the corresponding frequency that is perceived by the listener. We'll get the correct answer. But what we are able to draw from this equation is that the frequency of a source is 900. The frequency of a source is 900. Why am I saying 900? This information makes me to understand. I know that here it is written frequency detected by a listen, but this is the frequency of a source. Why am I saying that? In the introduction of this lesson, I said that when the source and the listener are not moving and the source produces a sound, that very same sound or with its frequency, it is exactly what the listener is going to perceive because both of them are not moving. You need to take note of that. Exactly what the source is perceiving. Exactly what the listener is perceiving. It is exactly what the source has produced because both of them are not moving. So this 900 is the frequency of the source. Then the frequency of a listener, because it changed, we can choose anyone who will get the same answer. We can try and see if it is correct. Then for frequency of a listener, let's say I want to choose this one of 10. I'm going to say for 10, we've got 874. That is the frequency detected by a listener when you are here. Then we have the speed of sound. That's what we want. Then here we are just going to write V. Here for VL, we're going to have a 0 because the listener is stationary. The listener is stationary, meaning that we're going to have a 0. That's why we're going to write a V. Then we're going to have a V footer, which is the speed of sound which we want to calculate. Then what was happening with the source? The source was moving away, as we have already calculated that we have already concluded about that in 6.1.3. So the source was moving away. Remember, when the source is moving away, it means we're going to have a positive in the source. It means here we're going to have a positive. You know that when the source is moving away, we have a positive. When the source is coming closer, we have a negative. Then what is happening with the source is the opposition of what is happening in the listener. This part is the listener side, this part is the source side. The listener opposes the information that we use for the source. Then the frequency of a source, velocity of a source, since we have chosen 874, then here we're going to have what? 10. We're going to have 10. We multiply it by 900. Then we want to solve for V. We want to solve for V. This is just simple maths. This is just simple maths. I usually tell kids that when you solve a question, you find that one thing on the other side, it is in fraction. The other, it is not in fraction. What do? You divide by 1. You divide everything by 1. That is not in fractional form, so that everything can be in fractional form. Dividing by 1 is the same as doing nothing, because anything divided by 1 is equal to that thing. So here you'll have over 1 here. So this frequency is multiplying the numerator. Even here, this frequency is multiplying the numerator. I can write the upper part. The upper part is the same as V plus or minus VL all multiplied by Fs. You need to understand that that's how it's. We can even expand it as FSV plus or minus FSVL. I'm expanding the upper part. You need to understand that this Fs is in the numerator, is multiplying everything that is in the numerator. Then here we're going to have 874, which is equal to 900 V divided by V plus 10. Then what do? We cross multiply. We're going to have 874. We multiply it by V plus 10, which is equal to 900 V. Then here we're going to have 874 V plus 874 multiplied by 10. Let me get my calculator. 874 multiplied by 10. That is going to give us 8,740. 8,740, which is equal to 900 V. Then we take V to the other side. We're going to get 8,740 is equal to 900 V. We subtract 874 V. What do we get? We get 900. We subtract 874 volt. Then we get 26. 8,740 is equal to 26 V. Then we divide by 26. We divide by 26. 8,740 divided by 26. And what do we get? We get 336.15 volt. Meters per second. Why am I saying volt? Because I was solving electricity earlier today at school. So this is the speed of sound. This is the speed of sound. It's 336.15 meters per second. So that's how we are supposed to treat that question. Ladies and gentlemen, here is the 2015 November question paper. We have treated it. I want us to jump and treat another and show you that if we were to use 850, if we use 850, it means here we're going to have 850, 850, then here we have 850, we'll have 850. If we solve it, we reach the final answer, that answer will be accepted. For this question, they are accepting three answers, 1, 2, 3. So if you use any one of them, you will get the answer that is going to be accepted. You can further this. I won't dwell much on it because I've already explained to you that they can accept any one of them if you happen to use them. Okay. Ladies and gentlemen, let us go to another question paper. I want us to treat a question paper for 2017, November 2017. I want us to treat a question paper for November 2017. November 2017, it is a graph. We have a graph like that. The graph which is like that. We have a graph which is like that. That is the graph that we have there. And that graph I've got 170 and 130. You can see it is appearing on your screen. Okay, here is the question. Let us start. A police car moving at a constant velocity with its siren on passes a stationary listener. The graph below shows the change in the frequency of the sound of the siren detected by the listener. You can see that we are given a situation where the car is approaching the listener, then that very same car passes the listener and move away. That's what we have. Then the first question, 6.1, it says state dopplers effect. I'm not going to concentrate much on the definition, but it is very important. Doppler's effect is the what? The change in the frequency of sound detected by the listener because the listener and the source are moving at different velocities. The listener and the source are moving at different velocities to the sound propagation. So it is appearing on your screen, the definition. I won't pay much attention to it. You need to know it. Each and every definition for physics, you know it is going to be set in the exam, meaning that you need to know it. It is very important. Then we come to 6.2. We come to 6.2, 6.2.1. 6.2.1. 6.2.1 says, write down the frequency of sound detected by the listener as the police car approaches the listener. As the police car approaches the listener. You can see that there is a relative motion between the two. The police car is approaching the listener. So it means as the car is approaching, to approach is to move closer, right? Meaning that when the source moves closer to you, the sound that you are going to perceive or hear is going to be high. You understand? So it means that as the sound source is approaching the listener means coming closer to the listener, because we know that English is not our home language, it's not our mother tongue. And some of these words, as African kids, they make us to make mistakes. That's why I need to emphasize. That's why I'm encouraging all people from Limpopo to follow this channel, because we know the challenges that we face about language and everything, our geographical location and everything. So when we teach in a way that you are going to understand, looking where you come from, because these things of language, I know very well that they do affect us. Ishulungu, Shatik, you understand? Okay, let us move forward. 6.2.1. We need to write the frequency that the listener is going to perceive as the car is approaching. So when the car is coming closer, it means that will be the larger frequency, 170 hertz. It's going to be 170 as given in this graph. This is the frequency. This is the frequency in hertz. Frequency in hertz, and that is 170. It is greater because the source is coming closer. Then 6.2.2, when it is moving away, when the sound source is moving away, when the sound source is moving away, and obviously that will be 180 hertz, because when the sound source is moving away, it means that the frequency is going to decrease. When the sound source is moving away, it means that the frequency is going to decrease. Then let us go to 6.3. Let us go to 6.3. How do we tackle 6.3? 6.3. Let us tackle it. 6.3. 6.3 says calculate the speed of the police car. Take the speed of sound in air as 340. So we are taking the speed of sound in air as 340 meters per second. The speed of sound in air, we take it as 340 meters per second. So that's how we're going to move. The speed of sound in air, we take it as 340 meters per second. Then they want us to calculate the speed of the police car. The police car is the sound source. So let us calculate that one. Let us calculate that one. And you can see that there was no point in this question where the police car stopped. There was no point where the police car was moving at 0 meters per second, meaning that from these values, we do not have the frequency of the frequency of the source. These are the frequencies of the listeners. At least if you were told that at this point the source was moving at 0 meters per second, you will say that this 170 is the frequency of the source. So that is not so in this case. We are not given the frequency of the source, meaning that we're going to have two unknown. And you know, as we are people of science, people of maths, when we have two unknown, we know that we can be able to solve something that have got two unknown. Because you can see here, we don't have the frequency of the source. These are the frequencies that are perceived by the listener. These are the frequency heard by the listener. Because there was no time where the car was moving at 0 meters per second. We know that when the listener is stationary and the source is stationary, the frequency of a source and the listener, they are equal. Yeah, you can add that into your notes. When the source is stationary and when the listener is stationary, the frequency of the source and the listener are equal. So this is not the case. We were not told that, meaning that we need to start by writing our formula. I'm going to move up. We start by writing our formula. V, not V, F, L is equals to V plus or minus VL over V plus or minus Vs multiplied by frequency of a source. That's how we deal with this one. You start by writing the formula. You are copying it as it appears in the formula sheets. Don't try to change anything. Don't rush. Write it as it is. You get your 1 mark. Because you, our learners, we know you. You are not the same. Someone can be able to change and manipulate it and still get it. Someone won't be able to do it. And when we mark these questions, we mark the formula, we mark the correct substitution. If you do correct substitution, trust me, you are going to get almost all marks. The only thing that you're going to get wrong is one thing. That will be the final answer. Imagine with a very complicated question as presented. But if you write the formula, you do correct substitution, we give you full marks. So it means you are safe with Doppler's effect. It is very easy. Okay, then let us start. The frequency of a listener, we're going to start by 170. That is the frequency of a listener. Then the speed of a listener. The listener, we are told that the listener is stationary. Let me check again. It says a police is moving at a constant velocity with a siren on. Passes a stationary listener. The listener is stationary, meaning that here we're just going to have the speed of sound, which is 340. VL is 0, so we're not going to write anything. Then here we have V, which is the speed of sound in a medium. We're going to have a 0. Then let us look at this. 170, it's when the source was approaching the listener. This is linked with the question that is asked in the previous question, the question that I asked in 6.2.1 and 6.2.2. This 170, the listener, the source was approaching the listener. This one of 170, the source was approaching the listener. So we know that when the source is approaching, we are going to have a negative. When the source is approaching, we're going to have a negative. Then we have velocity of a source. Then we have this. We don't know frequency of a source. And please, one of the mistakes that you do as learners is to try to lie, because you are given two frequencies here. You just try to lie. You make one to become the frequency of a source, and you make the other to become the frequency of a listener. That is incorrect. Do not lie. If you are not given something, or if you don't see it, don't try to cheat. Write it as it is. It will lead you to an answer. Or maybe there is no answer. Who knows? So don't try to cheat. Then it is like this. Then this is the first equation. Then we come to number 2. Number 2, we substitute in the formula. When the source is moving away, we know we're going to say the frequency of a listener. When it is moving away, it is 130, which is equals to V 340. Remember, the listener has always been stationary. Then going to have 340. When the listener, when the source is moving away, we are going to have a plus here. Then velocity of a source that we are going to calculate, frequency of a source. Then that's what we have. We have 2 equations. So notice, for writing this, how many marks is the question? It is 6 marks. So for writing this formula, you write this and you write this, already have got 5 marks. You see, you haven't solved anything, you just substituted. Then we are going to manipulate everything using mathematics. We manipulate everything using mathematics, then we go to the final answer. That final answer have got 1 mark. So meaning anything that you will do, and which is the longest step of note, it have got only 1 mark. So to get to get marks for this Doppler's effect is very easy. You just need to make correct substitution. Then let us make some substitution. We are going to solve it simultaneously. How do you go about it? We're going to have maybe, let us check the first one. We make Fs or Vs the subject of the formula. We'll see which one it will be easier. Then we come and substitute here. Then we get Vs. It is going to be a long process, but it have got 1 mark. 170 is equals to 340. 340 multiplied by frequency of a source. Then 340 minus velocity of a source. Then you can see, I told you when we have one part which is in fraction, the other is not, we make everything to be in fraction by writing over 1. Dividing by 1 is the same as doing nothing. Anything divided by 1 is equals to that number. Then here we're going to have 170, we multiply it by 340 minus Vs. Here we have 340 Fs. 340 Fs. You can see what we have. Then what do? We divide by, can divide by 340. We divide by 340. We are dividing by 340 so that we can be left with Fs. Then Fs is equals to We have divided everything by 340 there. 170 divided by 340. 170 divided by 340, that is going to be 0.5. So we're going to have 0.5 340 minus Vs. So meaning that anywhere there is a Fs, we're going to write 0.5 minus Vs. Let us substitute in the second equation. I hope you are understanding what we are doing. We created these two equations, equation 1 and equation 2. It's just that I don't love writing equation 1, equation 2. I just don't love to write equation 1, equation 2. Maybe it's because I'm a physics teacher. Then we substitute this to the first equation. We started by that one of 170. It means we need to substitute to that one of 130. It means where there is Fs, we substitute this. It means going to have 130 is equals to 340 over 340 plus Vs. Then here, we're going to substitute what? 0.5 multiplied by 340 minus Vs. That's what we have. That's what we have. Then let us solve. Let us solve. This is 130. Then we have 130, which is equal to, you know that this 340 is multiplying everything that is in the numerator. So we're going to have 340. Before maybe we can multiply, let us just simplify everything by removing this 1.5. We multiply everything by 0.5. I mean 0.5 multiplied by 340. It is going to give us 170. Is that correct? Okay, it's going to give us 170. Then what do we do? 170. It means we're going to have 170 minus 0.5 Vs. Yes, that's what we have. 340 plus Vs. Yeah, we have simplified everything. Then we try and solve. 330 is equal to 340 multiplied by 170. 340 multiplied by 170. That is giving us 57,800 minus 340 multiplied by 0.5. 340 multiplied by 0.5, it gives us 170 Vs. Then we're getting there. 340 plus Vs. Remember that everything that we're doing it for 1 mark. So someone, don't be frustrated, you know. Some other things, they may be difficult. You just try to solve, you get it wrong, maybe. You have already got 5 marks through substitution, so do not be discouraged by these long steps. You are doing this for 1 mark. In physics, we don't mark maths, we mark only substitution. Then when it is like this, you can just cross multiply. We're going to have 130, we multiply it by 340 plus Vs, which is equals to 1 multiplied by 57,800 minus 170 Vs. Can you see what we have? Then we multiply 130 multiplied by 340. 130 multiplied by 340. We see what we get. 130 multiplied by 340, we get 44,200 plus 130 Vs, which is equals to 57,800 minus 170 Vs. You see what we got? Then we take everything, the Vs this side, we take the numbers to the other side. We're going to have 130 Vs plus 170 Vs, which is equals to 57,800 minus 44,200. You see what we have? Let us see. 130 Vs plus 170 Vs. That one will give us 300 Vs, which is equals to 57,800 minus 44,200. That will give us 13,600. Then we divide by 300 to get Vs. We divide by 300. Then our Vs is 13,600. We divide by 300. Then what do we get? We get 45,33 meters per second. So it means that our source is moving at 45 meters per second, 45,33 meters per second. If we want to confirm that we calculated the correct thing, we can just take it and substitute here. It means we must get 170. Can we do that? It means we must get 170 if we were to substitute everything back and we see what we get. So that is our VS. That is our VS, 45,33. Ladies and gentlemen, we are done with the 2017 previous question paper. I think we can just do the last one. The last one. Then we'll be done with this topic of Doppler's effect. Please take note that we have videos that are teaching all topics. So if you are supplementing your exam, or tell someone who is writing their supplementary exam that there is a channel that is teaching all topics for physical sciences, you can just go to YouTube, you just go and watch, you go and support, then you pass your exam. You don't have a reason to complain, you don't have a reason to worry, because everything it is here. I'm still here. Now we are going to 2014 February March exam. We're going to 2014 February March exam. That is a supplementary exam. I usually advise you that normalize treating supplementary exam previous question papers, because sometimes they are difficult. In most of the time they are difficult, but standardized, covering the scope but difficult. So please check supplementary exam. I want us to treat one. It's a February March exam 2014. And in 2014, can I tell you what was happening in my life in 2014? In 2014, I was doing my matric. I matriculated in 2014. I was in grade 12 in 2014. Actually, I'm one of the first groups of people to write the exam for CAPS. I'm the first group to write the exam for CAPS. It was in 2014 where CAPS was in grade 12. Because it started with us when we were in grade 10, grade 11, then grade 12. So we are the first group that wrote CAPS grade 12. Okay, let's start with this matters. Let us start with this matters. February March exam 2014. The question paper is appearing on your screen as I speak. Question number 6, Doppler's effect. The question says, a sound source on a car produces sound wave of frequency 850 Hz. A stationary observer measures the emitted frequency using a detector which can measure a maximum frequency of 800 Hz. The detector can measure a maximum frequency of 800 Hz. Then we find that the detector only registers a reading while the car is moving. You notice that the detector only registers a reading while the car is moving. Then we come to 6.1. Must the car move toward or away from the observer detector to register a reading? Must the car move away or closer to the detector? I mean for the detector to register a reading. Okay, let's start 6.1. 6.1. Let me explain that situation. The person is having a detector, although this is a calculator, a detector. This detector can only detect maximum hertz of 800. It can register up to 800. But the sound source is producing more than 800. It's producing 850. You understand? Meaning that this thing, it is not going to measure the correct frequency that is being produced, because it can only register only up to 800. 800 and above, it cannot be able to register that. It's not going to be able to give a reading for that. So you see, we have a problem now. So the question says, must the car move towards or away from the observer for the detector to register? Remember, already the sound that is being produced, it is up, it is very high, 850, and this detector can only detect 800. So if this detector can move closer, or the car can move closer to the detector will not give any reading. The detector will not give any reading because it can read up to 800. Because if the source comes closer, the frequency will even increase to be more than 850. So it means in order for this detector to give correct reading, it must be moving away. When it moves away, the frequency from 850 will be decreasing. Then it will get to a point where it will start registering 800 going down. So the answer for 6.1 is away. The answer is away. But the question says explain the answer by referring to frequency and wavelength. Explain your answer by referring to frequency and wavelength. What is happening in the introduction of lesson 1, Doppler's effect? Please make sure that you watch lesson 1, Doppler's effect. In that question, we related frequency and wavelength. We know that when the wavelength is longer, the frequency is going to be shorter. So it means that when wavelength increase, when wavelength increase, then frequency decrease. Frequency decreases. So it means in order for that reading to be recorded by that detector, the frequency must be decreasing, because already the frequency is higher than the maximum value that that detector can record. So the wavelength must increase. To increase wavelength is to make the particles like to be far apart. That is increasing the wavelength. Then the frequency is going to decrease. So that's how we are supposed to explain that one. 3 mark, 1 mark for away, 1 mark for this one, and the 1 mark for the relationship. So that's how we are supposed to answer that one. Then I love this one because it is straightforward. It is not long. I love this one because it is straightforward. It is not long. Then it says, calculate the maximum speed at which the car must move for the detector to register the maximum reading. Take the speed of sound in air as 340. We need to be careful about this question, because this question is trying to relate the motion of the car. There's a relative motion here. It is trying to relate the motion of this thing. It is saying calculate the maximum speed as at which the car must move for the detector to register the maximum reading of to register the maximum reading. Yes, take the speed of sound in air as 340 meters per second. So how do we calculate that one? We start by our formula. I told you that when you write the formula as it appears in the formula sheet. Write the formula as it appears in the formula sheet. You get your 1 mark. Then you substitute, you get your marks. Then final answer, I've got 1 mark. So do not try to trouble yourself. You got this. You got this. You are with me. The Billafied, Mr. Billa. You got this. Okay, let us move. We start. The question wants us to find the maximum speed at which the car must move. The maximum speed at which the car must move for that detector to detect the maximum frequency, meaning that the frequency of the detector, this time the listener is the detector, it must be 800 because that is the maximum. Notice that we are not using 850. 850, yes, 850 is the frequency of the sound that is being produced. 850 is the frequency of the sound that is being produced. So here we need to write what? We need to write 800, the maximum frequency of a listener. Then we come, the speed of sound in air, they said you must use 340 plus or minus velocity of a listener. Velocity of a listener. Let me read the question again. A sound source of a car produces a sound frequency. A stationary observer may, yeah. So the listener is stationary. Stationary, meaning that we're going to write 340. Then velocity of sound, speed of sound. Then what is happening with the source here? We have already chose that the car or the sound source must move away. So it must move away. When it moves away, we have a positive here. Then velocity of a source, that's what we are calculating. Then the frequency of a source. The frequency of a source we were given, that is 850. That is 850. So this is simple and straightforward. Simple and straightforward. How many marks? 5 marks. So already you've got 4 marks. Then the last mark for final answer, it's only one. So in physics, we mark substitution, formula substitution, and final mark. So you see you have substituted. For this one, you have got 3 marks. This one, 1 mark. Then 4. It's simple. Then we'll have 800, which is equals to 340. 340, then let me write for you to understand. 340, this 850 is going to multiply with 340 because we're going to put over 1, as I told you. Then it is at the top. Then here we have 340 plus Vs. Then let us calculate what we have. We have 800 over 1, obviously. Then 340 multiplied by 850. 340 multiplied by 850. 340 multiplied by 850. We'll get 289,000. Then we have 340 plus Vs. Then we cross multiply. We're going to have 800 multiplied by 340. 800 multiplied by 340 plus Vs. Then we have 289,000. 289,000. Here, this is 340, guys. This is 340. This is 340. Then 800 multiplied by 340. 800 multiplied by 340 is 272,000 plus 800 Vs, which is equals to 289,000. Then we take this 272,000 is 272,000. I wrote 10. Let me confirm. 800 multiplied by 340. That's 272,000. 3 zeros. Then we take it that side. We're going, can I please complete it here? We're going to have what? We're going to have 800 Vs, which is equals to 289,000. We're just taking this one downside, it will become negative. 289,000 minus 272,000. What will we have? We have 17,000. We divide by 800. Divide by 800. Then Vs is going to be 17,000 divided by 800. Then we get 21,25 meters per second. So it means the maximum speed that source must move, it is 21,25 meters per second. So this is the velocity that car is going to move. This lesson has been very long enough. We are going to do the latest question, whereby we are using equations of motion to calculate the velocity of source, then we later on come back to this. It's another type of a question that we need to know how to treat, because they set this kind of difficult question for our exams, the trial, the June exams. You know, June exam and trial, they make them to be difficult. And those exams, they contribute to our SBA, and our SBA also contribute to our final mark. So we need to practice everything. Don't say that I will be serious by December time. No, everything counts. Everything counts. It's very important. So this is our answer of the velocity of the source. Then let us treat the last one. Let us treat the last one. How do we treat the last one? The last question wanted us to talk about one use of Doppler effect. One use of Doppler's effect. One use of Doppler's effect. What is the use of Doppler effect? We know is to measure blood flow. Number one is to measure blood flow using a Doppler flow meter. So some of the answers, they write Doppler flow meter. I don't understand Doppler flow meter. How is it a use? Unless you write something that it is used for this and this and this. Writing Doppler flow meter, I don't see it as a use, but they do mark that. The examiner do write that. So it measures blood flow through the Doppler flow meter. Then number two, it is used to measure the heartbeat of fetus, the heartbeat of fetus, the heartbeat of a baby, the heartbeat of a fetus. Number three, what can we say? Predict precipitation. Predict if it's going to be rainy, snowy through the Doppler radar. Doppler radar. So this one is Doppler radar. Doppler radar. Doppler radar. This one is what? This one is Doppler flow meter. Doppler flow meter. Doppler flow meter. Even this one is Doppler flow meter. Number four, then we talk about ultrasound. Ultrasound, which is to create image of fetus. Image of fetus. Ultrasound is used to create the image of a fetus. So ladies and gentlemen, we are reaching the end of this lesson of treating previous question papers. We've treated 3 question papers: 2015, 2017, 2014 March exam. In the latest lesson for Doppler's effect, we will try to treat a question paper that have to use equations of motion to get the velocity of a source. Then we will also talk about light. We will also talk about red shift and blue shift. Ladies and gentlemen, thank you very much for watching. Keep on watching. Make sure that you subscribe. We've reached the end of the lesson.